Good afternoon to all of you. I hope remaining participants will join. We have the speaker, Dr. Vijay Krishnamurti, who is currently working at IIIT Kanjivaram. So, Dr. Vijay Krishnamurti obtained his BTech and MTech both from NIT Tiruchirappalli. So, his research interests includes power electronics and drives, smart grid, application of machine learning and artificial intelligence to energy system, embedded controllers, industrial electronics, and renewable energy systems. After submitting his PhD thesis, he went to Singapore for his postdoctoral fellowship. He spent his short time there. Then immediately he joined at MNIT Jaipur, and he was there for some point of time. So in the year 2018, I guess he joined at IIIT Kanjivaram, where he is currently working. So he is one of the active researcher in both power system as well as power electronics. So he has won many awards, such as Institute of Engineers Young Engineer Award for the year 2017-18, Young Scientist Award in the year 2015 by SERB, POSOCO Power System Award for his PhD, doctoral PhD thesis. I hope he also the recipient of Vishwesharaya Young Faculty Research Fellow, I hope. So he has published more than 25 international journals and over 21 international conferences. So he is going to deliver a lecture on overview and various components in electric vehicle systems. With this brief introduction, I invite Dr. Vijay Krishnamurti to deliver the lecture in this FDP. On behalf of all the participants and my own behalf, I heartily welcome Dr. Vijay Kumar. Welcome you, sir.
Yeah, thank you, sir. Very good afternoon to one and all present here. And just I would like to thank Dr. Gumar sir for giving me this opportunity to interact with you all. It's my great pleasure to give a talk on this wonderful FTP. Thank you, sir. I and Kumar sir both are very good friend, and we are working on the same area of research in a couple of years. So here today I'm going to talk about components of electric vehicles. I hope it will be helpful for you to start up some research in this area. If you are having any questions or clarifications, please interrupt me in between, and you can ask me anything you want from my presentation. So now I'm going to flip my laptop as a writing pad. So now I'll switch off my video and I'll share my slides. I hope you can able to see my slides now. So please, if you have any doubts or any questions, please ask in between. I'll be happy to answer to your questions. Right? So you can able to see my slides. Any participants?
Yes, sir. Yes, sir.
Yeah, sure. Yeah, sure. Yeah, thank you. So here, first we are going to see that electric vehicles overview, and we can start with when they have started and why they have come up with this electric vehicles and all we will discuss. Then we will move into the various components of the electric vehicles and what are the vehicles it's available in the commercial market. That also we are going to discuss in this session. So when we look at that electric vehicles history, even in 1830 itself, we have the small electric vehicles in Hungary and Netherlands. Then afterwards, they have developed the electric vehicle based on crude. That means based on gasoline. So in 1830 to 1870s, there are a lot of vehicles come up with the crude-based vehicles. That means using the crude, they have generated the electricity. From that electricity, they have driven the vehicle. Then in 1819, we can see the first electric vehicle come into the US market. Then if you look at then 1901, just they have come up with that hybrid electric vehicles. Then at the same time, if you look at it, in 1920 and 1930, there is a decline in the electric vehicle. That means they have reduced the usage of electric vehicles. The reason is they have come up with the crude oil very cheap, so that people have go with the oil-based electric vehicles. That means it's internal combustion engines and all they have used. Not here the internal combustion engines, just they have used the crude oil for generating the electricity. So then in 1973, they have come up with the next generation of the electric vehicles. So here GM, General Motors and all come up with that prototype of that electrical car in that symposium. Then afterwards, if you look at it in that 1979 and all, again the crude oil coming to the picture with the cheap, so that that time again people have shifted to the gas powered or gasoline powered cars. Then afterwards they have come up with that IC engines and all. Then there are a lot of vehicles they have rolled with this IC engine based. Then afterwards, there is due to of the policy, people have shifted to the alternative energy sources. So that time again, the EV gains the momentum. So that afterwards again, people are started to work on that electric vehicles, and only they have used that coal, this oil and gas for generating the power, and they have used that power to run up the vehicles. Then if you are going with the larger vehicles like buses or trucks, they have come up with the they have come up with the oil-based vehicles. Then afterwards, if you look at that railways, then they have electrified the lines. From the earlier, they have used the steam engines. Even we can see some of the engines are steam. Then afterwards, then they have electrified that railway to run with the electricity. So in the same way, in the cars, that means in the passenger vehicles also, they have drastically increased. So in this case, then they have come up with the batteries with the electric vehicle. So in we can say in 2000, people have started to work with the electric vehicle with the batteries. So this is the development. It happened in the electric vehicles. Then if you look at that journey after 2000, even it's very, we have to note it down, this company, this very much. Even this company is talk of the town today, the Tesla Motors. Even if you look at US, their market share goes very high. Even he is the number one wealthiest person in the world, Elon Musk. So he is the owner of the Tesla Motors. So because of this technology here, the market brings to him in the wealthiest position. So that's what people are now talking about, the electric vehicles. Even recently, even if you look at 15 days before, there were a news that Tesla coming to the India. So they have registered the company in Bangalore, Tesla India. So even there were some rumors that they are going to tie up with Tata Motors to launch the electric vehicles, but it's not on the paper, still on the rumor side. So that's what it's a development happened in worldwide. People are shifting towards electric vehicle. Even when we come into that Paris Agreement, they want to reduce the pollution, that means carbon emission. So for that, they are looking for the alternative fuels. And in the transportation also, people are come up with the electric vehicles. So that's what now, if you look at it in 2010, GM releases the plug-in hybrid vehicles commercially. The 2010 is the commercial electric vehicles coming to the market. So here, when we talk about recent trend in 2013, people are talking about when the people are talking about the electric vehicles, the battery come into the picture, because the major part of the electric vehicle is battery. So what type of battery they can use it in the electric vehicles, and what is the energy density we require? Even a single charge, how many kilometers we can run up that electric vehicle? So that and all, it's a question comes in front of the consumers. So how we are going to satisfy the consumers to sell the electric vehicles? So these developments and all we will discuss. So what are the components and how much battery we have to select to run the electric vehicle, that and all we will discuss. But battery plays the major role. Even if you look at it, when we talk about the electric vehicle theme, then the battery manufacturer also is coming to the picture. So there are a lot of startups with a battery storage system, battery and storage system development. Even in India, for developing the battery, we are depending upon the China. A lot of electrodes and all we are importing from the China, and just we are assembling it here. Even with recent development, Make in India and other schemes, in India also, we are having a indigenous battery manufacturing technology in India. With even there are a few manufacturers like Amaran, AICTE. Even there are a lot of companies, they are working behind these companies. Like we can say is Tata Chemicals and all, they are working. Even you may hear about it. The Tata Chemicals, they are coming up with a big plant in Gujarat for manufacturing the lithium-ion batteries. So these are the developments happening in the battery side. So then in future, so what are the talk on the electric vehicles? So when you are talking about the electric vehicles, obviously you need the charging stations to charge your vehicle. Even if you charge your vehicle in your home, you can drive your vehicle for 100 kilometers. After 100 kilometers, your charge may be dried. So that time, how you charge your electric vehicles? That's a question. So that's what even in India, like Power Grid, Tata Power, Adani Power. So these are the players. They are creating the infrastructure for charging stations. So the charging station also it's important thing. So how you can make the charging station? That also is a question mark. And how much time your vehicle need to park in the charging stations to get charged? So that and all is a constraints when you are going for the electric vehicles. And when you are connecting your vehicle to the charging station, for example, in a commerce, we can say in a charging stations, that may in a park and charge kind of thing, or in your home, you can able to park your vehicle on that parking lot and you can able to charge it. So during night, you are connecting your electric vehicles with the network. So that time, if your battery gets fully charged, that time your battery can act as a energy storage to your distribution network. So for that purpose, we need the aggregators. The aggregators can aggregate all these electric vehicles which are connected to your network. Then they can aggregate that energy storage. Then they can then they can come up with some energy management algorithms to play with your smart grid technologies. So that and all is the future of your electric vehicles. So that's what now we are focusing much on the electric vehicle technology. Okay, so another question is why we need EVs. So it's an obvious thing. So when you are going for electric vehicle, the main thing is you can able to reduce the fossil fuel usage. That's a great thing why we are moving to the electric vehicles. And another thing is to reduce the carbon emissions, or you can say it's the greenhouse emissions to the environment. These two are the major points you have to consider for moving to the electric vehicles. When we look at that oil demand and production in the world, just the blue line is your oil production and your red line is your oil demand. Here, for every year, the oil demand keep on increasing exponentially, but the oil production is reducing. That means we can say we have attained the saturated condition. However, in during this pandemic period, the oil production is more than the demand. That's what if you look at in the market, the crude oil price is crashed. So even you can able to buy the 1 barrel of oil for $15, $15, right? Even $5 also it's reached, right? So that kind of oversupply happened because of the pandemic. No industry has run, no vehicles on the road, so that production is more than the demand, right? But in future, if you look at it, if all industries or all vehicles on the road, then your oil demand will be increasing. At the same time, when we look at that carbon emission, so the first is total one. This is the total, and this is the CO2 from oil, burning the oil, and next one is burning the coal, then from the cement industry. So if you add these three, if you look at that, total is keep on increasing. So just we are emitting the more than 10,000 tons of CO2 to the environment. So think of it, how much we are polluting the environment. The same way, if you look at the temperature change in the world, so even the temperature changes keep on increasing. Even if you look at in the century wise, almost 0.2 degrees centigrade, we are increasing the temperature. Even you can realize yourself, even in 1990 and 2020, what is the temperature on the same month, right? So the month, if you take the month of January, so whatever the temperature you got in the 10 years back, definitely just you may get the increased temperature this year. That means earlier if 20 degree means now just you may get 20.2 degree centigrade, right? So this kind of temperature profile also it's increasing. So because of this greenhouse emissions, just your harms the environment with the CO2, CO, and nitrogen oxides and all, right? So that's what here, even in the panel on climate change, they have declared that they have observed that increase in globally average temperatures from the mid 20th century is likely due to the greenhouse gas emissions. So that's what they have come up with the panel to reduce the carbon emissions. So in that, they have created with the Paris Agreement. As per Paris Agreement, they want to reduce the temperature rise of 2 degrees centigrade of every century. We can say every 10 years. So that they have to reduce that 2 degrees centigrade to half of it. Then even you may hear that news that earlier when Trump was in power, so he was out of this Paris Agreement. So even when the President Biden came into that power, immediately on the first day, he signed the Paris Agreement. I hope you have seen the news, right? So that means that the US also can contribute to reduce carbon emissions. So which country they are polluting much? Can you able to say any idea about it? Which country we are polluting much? Even if you look at the statistics, they may say this country is emitting a lot of CO2 to the environment. So do you have any idea? Even Trump also made some statement in between. I hope you remember, right? They were, I mean, they used to cite India, sometimes India and China. They will say we are emitting a lot of CO2. I mean, in the percentage wise, they will say. Even if you look at that percentage, if you look at the percentage wise, we'll be in the top. But if you are considering the average, so average per person, in that case, this developed countries like Germany, France, even we can say it's US and all, they are emitting a lot of gases to the environment as compared to us. Even if you take average per person, US and even Germany are giving more. But whenever people are talk about the percentage wise, they will cite us. That's not true. But we are in the good level. But we have to reduce it. Obviously, that's a good. That's a point here. So climate change, and we are looking at the renewable energy integration to reduce the carbon emission. At the same time, we can make our grid clean and greener. So for that, just we are integrating more of renewable energy into the grid. Even even MNRE targeting that by 2020, they are planning to integrate 175 gigawatt into the network. When we talk about electric vehicles, again, there is no fuel and no emissions. So we need not to have any kind of fuel for the electric vehicles, so that there is no carbon emission to the environment. At the same time, we are looking for the cheaper running cost. So we have to reduce the running cost of your vehicle. But now we have to invest much. Even the electric vehicle cost is. Do you have any idea for with the same power of your car? If you want to buy any car, so what is the cost of it? We can say, okay, you can take Swift Desire. So with the same power of vehicle you want to buy, so how much cost you? Do you have any idea? Even recently, Tata also launches their electric vehicle, right? Any idea on it in India? Anyone? So participants, they can able to unmute themselves, right?
Yes, sir.
Yeah, sure. Okay. So any idea of the electric vehicle cost in India? Even Tata recently they launched electric vehicle, right? So it's very cheapest one. It's starting from 20 lakhs, right? So do you have any idea about the Tesla cars? So Tesla cars around 1 crore rupees. So that's what there were a talk who is going to purchase the Tesla cars in India. So that's a question mark. Even their minimum cost is 1 crore rupees. But you can see their SAT prices and all, it's going very high, and he become number one person, wealthiest person's list, right? So that's the case. So when people say the running cost is cheap, but the capital cost is higher. So that's what Tata, they come up with the indigenous technology, and they are doing the same specification of the cost with the 20 lakh. So that's a minimum cost as on today. In future, if scrappage policy and all coming to the picture, then again this 20 lakhs will reduce to 10 to 12 lakhs rupees. Right? And again, when we talk about electric vehicles, the speed, right? So how much speed we can go with the electric vehicles? That's a question mark. Even the Tesla cars and all, they can come up with the speed of 300 miles. If you charge your vehicles, they say it's 300 miles. That's earlier. Now even the Tata itself, they are saying that within a charge you can able to drive 1,000 kilometer, right? 1,000 kilometer range you can able to drive it. So that and all, I mean, when the time moves, this range also will increase. And another good thing is because of this EVs, you can able to reduce the less health problems. How you can see means, even if you go to the Delhi, you know the present condition. Even the Delhi, if you are staying for 6 months or 1 year, obviously you'll get asthma problems, right? So this, suppose if you get a asthma, then you have to pay a lot of money to the hospital. So if you consider this cost, you can reduce your pollution, then live with a good health. So that will give you a much cost saving. So that's what, instead of spending a money in a hospital, you can spend in for your daily requirements with this kind of green activities. You can able to reduce the total cost of the human being. So this and all, just we have to do some kind of analysis and we have to come up with the point. So that and all is possible with the EVs. At the same time, if you come up with the EVs, we won't get that much vibration as it is in the internal combustion engines, IC engines, right? And when we talk about electric vehicles, there are very less moving parts as compared to the IC engine. So in IC engines, they are having a lot of moving parts that create a lot of noise. But here in electric vehicles, here there is no, we can't say there is no moving part. As compared to the IC engines, we are having the less moving parts. So because of that, even if you run your electric vehicle, you won't get a sound in it. Even I hear from one of my friend in electric vehicle industry that because of there is no sound in this electric vehicles, there might be a chance to get into some accidents. For that purpose, they are creating some noise with the external circuitry and all. So that's what it's happening in the electric vehicles. And here, maintenance wise is very cheaper. So in IC engine means you have to spend a lot of money for services. But when we come into the electric vehicles, you need not to spend much money for maintenance. Only thing is this battery, and you're having your electrical drives. So this is the costliest part in the system. So as compared to the IC engines, here the maintenance is less. And here when we talk about EVs, it's connected to the grid. There are a lot of opportunities in the smart grid technologies like ancillary services and reactive power support. How it possible means by aggregating all the EVs in the system, then only you can able to achieve this ancillary services and reactive power support and all. So that and all we'll discuss in future slides if possible. And when you come into the safety side, here electric vehicle weight is, we can say, we can able to reduce the weight once if we are having the good technology with the battery. So even people are working with a lot of things in the battery side, so that here we can able to improve the safety as compared to IC engines. Here they can say it's a lower risk of fires and explosions. Only here the explosion part is battery as compared to the IC engines. But for that also they have come up with some safety measures and all in this battery side. When we come into the electric vehicles, we can classify that electric vehicles as IC engines. We can say it's internal combustion engines vehicles, HEV, hybrid electric vehicles. So in that hybrid electric vehicles, again, you can have mild hybrid vehicle or fully hybrid vehicle. So in this fully hybrid vehicle also, whether you are connecting your IC engine with the motor drive series or parallel. So depending upon that, you can say it's a parallel HEV, series HEV, and you can say it's a plug-in hybrid vehicles and all you can classify here. Then another type is a fully electric vehicles. That means full electric vehicle means you are not having any internal combustion engine in it. So you are having pure electrical system in it. So battery electric vehicles and fuel cell electric vehicles. So these are full electric vehicles. They will say it's a full EV. So other than that, if you're having a hybrid electric vehicle means just you are combining your IC engine with the electrical drive. So here, then IC engine means is nowadays we are having all IC engine based vehicles, right? Okay, so you can see here the comparison, the CO2, or you can say gas emissions of IC vehicles and battery operated vehicles. So in the battery operated vehicles, the gas emissions are drastically reduced. Even if you look at that IC engine based electric vehicles, carbon monoxide is 100%. So here you can see here it's very less. So even other gases also it's reduced, right? So in comparison to the IC engines, the electric vehicles are preferred. Okay, so now we can compare the energy diversification between the EVs and IC engines. So here, if your vehicle is fully operated with oil, that means petrol or diesel, that engines, that vehicles will be called as internal combustion engine vehicles. Then next to this diesel and petrol, we are having the gas operated, that means LNG or LPG operated vehicles. So that also we can say it's a hybrid vehicles, right? So even now we are increasing, even in the Delhi also, they made a compulsion that all taxis should be in the LNG and the LPG. So even the LNG and LPG stations are available in the city, right? So next, if you look at here from this part up, all are electricity operated vehicles. Electricity operated vehicles, first you can use coal or biomass for generating your electricity, and you can connect your electrical drive, then your machines your vehicles will operate. So in this case, from this electricity, by using the electricity, you can able to generate the hydrogen, right? So once you are generating the hydrogen, then by using the hydrogen, you can able to operate the fuel cells. So the fuel cell operated electric vehicle also is coming to the fully electric vehicle. So based on how much you are hybridizing with this diesel and petrol based vehicles, that hybridization will, depending upon the hybridization, we can classify the vehicles. Okay, so now we can have a comparison of EV and IC engines. Once if you understand this comparison, then we will get to know why we are moving towards electric vehicles. You can see that efficiency. Efficiency means you can say tank to wheel efficiency. So just you are in your vehicle, you are having the tank, then you are filling the petrol, and you are driving your vehicle to reach your destination from one point. So in this case, you can see that electric vehicles. So we are having electricity, 100% it's available. Then for charging the battery, just you will get the 2% loss. So just you are getting the 98% efficiency from the battery. So then just you are having the power electronic converters and motors. So in that you will get losses. Then finally on that electrical drive side, you will get the 78%. So in this 78%, you are giving to your drive line. So that drive line output is 72%. So on the wheel, we are getting the 72% of the energy, 72% of the energy. At the same time, if you look at that fuel cell electric vehicles, so hydrogen, you are giving the hydrogen to fuel cell, the fuel cell efficiency is 55%, right? So here, then from 55%, you are generating the power and you are giving to the motor electrical drive. Then from the electrical drive, 44%. On the wheel, you'll get 40%. On the wheel, you'll get the 40% energy. So we can look at that IC engines. So 100% petrol you are putting in it. And here the output from the engine is only 20%, right? Because of the thermodynamic efficiency. So because of the thermodynamic efficiency, you're getting 20%, then 3% loss in the drive line, then you'll get the 16% on the wheels. 16% on the wheels, right? So this is the efficiency comparison of electric vehicles and IC engines. Okay, now now earlier just what we have done, just tank to wheel efficiency only we have considered, tank to wheel efficiency. Now we are going to consider the well to wheel efficiency. That means you are getting a crude from the wells. So from the crude to your wheels, right? So we can see the efficiency of it. So in this case, just you are using the you are taking the crude oil from the well and you are refining it. So in that you can say it's a 95%. The power generation will get only 36% output. Then transmission again 34%, battery charging 25%. On the electric vehicle you are getting 18%, right? So on the wheel you are getting the 18%. The same crude oil you are using for refinery purpose. After refine that crude, you'll get a petrol. That petrol you are taking to that filling station and you are giving to your IC engine. So when you are talking about the IC engine, the efficiency on the wheel is 13%. That means you are getting the 13% energy on the wheel, right? So you can compare here, almost 5% is higher. 5% efficiency is higher than your IC engine. So that's what people are preferring to go for electric vehicles. Even that's what every government also is focusing on, to move into the electric vehicle concept. So this 5% is a huge number. As I mean, if you consider the whole, the 5% is a huge number. So that's what people are working towards the EVs. Okay, so when we come into that cost premium and fuel economy, depending upon the size of your size and hybridization of your electric vehicles, the cost also will keep on increase, right? At the same time, the fuel consumption of that vehicle also will be reduced. So when you are increasing the hybridization, even depending if you are going with the full hybrid, you can able to save much fuel. You can able to save much fuel. So that's what this graph shows. So when we come into the state of art of EVs, there are a lot of technologies in it. So the first one is motor drive technology. So in the motor drive technology, as we are electrical engineer, we need to focus much on this. So whatever the electrical drives we have developed, we have to see the feasibility to apply into this motor drive technology. Then again the battery. So batteries, chargers, even again the power electronics come into the picture for charge controllers and all, and the type of batteries. So that and all people, chemistry, they are working on a lot of technologies with the battery. So which battery we can prefer depending upon the performance and application of the vehicle. So that and all we'll look into this two topics. And the final thing is vehicle to grid technology. So obviously if your EV is going to increase, that's a huge task for the electrical engineers to develop some energy management schemes. Even you can come up with demand response management algorithms and all. So there, the vehicle to grid technology plays the major role in the smart grid. So first we will see the motor drive technology. So this is the core technology for EVs. So without electrical machines, we cannot think of EVs. So in EVs, we are going to use different kind of electrical drives. So when you are designing the electrical drives, you have to be very careful with the power density and the torque requirement of the vehicle. So based on that, we can able to select your electrical machines for designing the electric vehicles. So here, whenever we are talking about the electrical machines for EV, we will prefer high torque density and high power density. So torque density means with a small size that should give the high torque. At the same time, the power density. So the size may be small, then your power density also should increase. Power density should increase. So this is one requirement. And wide speed range. That means wide speed range means you can able to control your electrical drive in the wide speed range. So that is another requirement. At the same time, it should cover the low speed operation as well as high speed operation. So in a high speed operation, it's like they will say it's cruising. That means just should go without any frictions and all. But in a low speed, it's a creeping, right? Yes. Yes. Okay. So next, when we are talking about machines, that should give the high efficiency with a wide speed range. Even it should operate in the wide speed range. Your efficiency also should be in the higher side. But normally in the low speed operation, your efficiency will drop. So that also you have to consider here. And it should give constant power during the operation. At the same time, why we need high torque capability at low speed means when you are climbing hill climbing time, or if you are going means, then that time you're I'm getting some disturbance. Yeah. So that time just you have the high torque capability at low speed range. And when we coming to that reliability side, that should be high. That means you should not get any fault during the operation, and should be robust. Low acoustic noise. So low is not get more noise on the noise from the electrical motor, reasonable cost. So it's very tough to take all the points. So here these are the requirements, but depending upon the application, cost, and you can say the performance, you have to trade off between these points. You have to trade off between these points, and you have to select your electrical machine. It's very simple. So it's very tough to have all these properties in a single machine, right? So in that case, just we have to look at that application, performance, cost. Based on that, just we can negotiate with one or two, even 50% of the points. So now, when we talk about hybrid electric vehicles, so what are the requirements? So here I'm talking about the conditions at extreme conditions. So now when you are designing your electric vehicle, then you have to trade off. So in this hybrid electric vehicles, you need high efficiency with wide speed range, and you should have good voltage regulation during the regenerative braking, and you can able to integrate with the engine. So when you are going with the hybridizing your vehicle, that machine, or you can say that machine should be compatible with this IC engine. So that also is one of the point when you are going through the hybridization. When we are going to that machines, there are two types. One is commutator based machines, and another one is commutator less. So now people are looking for the commutator less machines. That means it's a brushless machines. So based on that, we can classify these machines. So whenever we are talking about the commutator based, all the DC machines come into this picture. And when we talk about brushless machines, your induction machine, synchronous machine, double salient machines, vernier machines also is coming to this commutator-less type. So in this induction machines, already we know two types. One is spool cage and wound rotor induction generators. In synchronous machine, based on that armature, just we are having the different type of synchronous motors. In double salient, even whether the permanent magnet in the stator or in the rotor, depending upon that, you can say is salient pole machines and vernier machines. So vernier reluctance machines and all, it's having the high torque and high speed capability. So that's what they are saying. It's a vernier based reluctance machines and all. So these machines normally they will prefer for high performance based EVs. So when we come into the machine technology, they will prefer vernier machines for high performance applications. So these machines will provide the high torque during the low speed operation. High torque during the low speed operation. At the same time, you can able to connect this motor directly to the drive line. So that's what we can say the vernier machines are suitable for direct drive applications. So with this radial flex morphology, there are a lot of EV machines. They come up with that axial flex, linear flex, and transverse flex. Normally, you can refer this author's papers, so you can get to know the types of morphology. Here, normally they will use radial flex machines in all the EVs. But people are working on this axial flex and linear flex, but the transverse flex is not suitable for commercial application. So that's what still even it's very tough in the real-time implementation. So that's what people are focusing on, the radial flex with axial flex or linear flex morphology. So there are advantages and disadvantages with each and every morphology. When we talk about axial flex morphology, it have the high power density and torque density. So that's the advantage of it. But here, just we are having the large axial force in that stator. So that will limit to the shape of that pancake. So that's what people will prefer for good performance machines. They will go with axial flex morphology. And linear flex, again, it's a linear motion, but it's not much attractive towards EVs. And here, when we talk about the transverse flex morphology, it's very complicated during the manufacturing and real time of EVs. So that's what, but it will provide the highest torque density. But implementation side, it's a huge question, this transverse flex morphology. So when we come into this motor drive technology for hybrid propulsion, they will say it's integrated starter generator and electric variable transmission. They will say it's ISG or EVT. So they will say these two technologies in the hybridization, whether it's ISG or EVT, electric variable transmission. So in this ISG, so ISG means it's integrated starter generator. As name implies, you will have the starter generator as a block box, right? So this block box is available in your electric vehicle. So that ISG can able to generate the electricity, as well as it will act as a drive during a running condition, and it will provide the ideal stop and start. Because of the generation, we can use it for regenerative braking, and it will provide the power assistance. So the power assistance means you can say you can able to control the speed of your electric vehicle. So because of this integrated, why they are claiming this advantages means because of you are having the starter generator. Starter means it's a power converter. So once you are having the power converter, you can able to achieve the 4-quadrant operation in it. So because of the 4-quadrant operation, you can able to achieve all these advantages with this ISD technology. The same way, electric variable transmission, it's having the ideal stop-start, regenerative braking, even the power assistance and everything you're having in this also. So here you can say in EBT, there are different types of gears. So the normally they will use planetary geared electric vehicle transmission in all the electric vehicles. So that is easy to implement as well as cost effective. And we are having the double rotor electric variable transmission and magnetic gear, right? So depending upon this technologies, you can say you can classify the EVT. So what are the energy sources you can use? So that's what earlier just they use the diesel or petrol to generate the power on the board, and they use that electricity to drive your electric vehicles. Now almost all the electric vehicles, they have come up with the battery storage systems. So you can charge the battery, then you can drive your electric vehicles. Or in a heavy vehicle side, there are fuel cell based vehicles. Even if you talk about the buses and trucks, almost they are electrifying it with the fuel cells. So when we talk about the energy sources in the technology, obviously it's batteries, ultra capacitors. So what is the difference between the batteries and ultra capacitors? So both are the energy storage device. So what are the difference between these two? Anyone? In EVs, we are using batteries as well as ultra capacitors, right? So what is the difference between these two? Anyone? Yeah. When we come into this, batteries is a high energy density, right? So this will provide the high energy density. But when we come into this, capacitors is high power density, right? Yeah, exactly. So here, so because of this high energy density, you can able to drive your vehicle for long distances. But when you want to high power at instant of time, these ultra capacitors provide the high power within the we can say within seconds or milliseconds. So that will give the pickup to your electric vehicles. So that's what whenever they are going with this energy storage system in the electric vehicles, they prefer hybridization of this energy storage. That means battery with the ultra capacitors, so that we can able to enhance the performance of your vehicles, right? Then another source is ultra high speed flywheels. But here, due to of this mechanical stability issues, there are less research on these sources, but people are exploring the option for incorporate this ultra high speed flywheels in the electric vehicles, but only limited research on this topic. Then another one is fuel cell based electric vehicles. Yeah, you can develop some power converter topologies for operating your vehicles with the fuel cells. So here the fuel cells disadvantages, you have to carry the cylinder, and the efficiency of the fuel cell system, another bottleneck in this, only 55% efficiency from the fuel cell stack. So that's what we said. As a one person, you should not be a marathon runner or you cannot perform in both marathon as well as sprint. So just we can, that's what we can classify the battery and ultra capacitors. Normally in the EVs, the batteries are playing the major role. So there are different types of batteries. Even you can see that life cycle of the batteries and the power density. That's what I told you, depending upon the vehicle application, performance, cost, we can trade off, right? So here we can say it's VRLA batteries. So VRLA means lead acid batteries. So VR means it's a valve regulated lead acid batteries. So valve regulated lead acid batteries, just it will have the average life cycle. And when we come into the power density, again it's the average. But coming to the cost wise, it's very cheap in the battery side. So that's what when you're saying lead acid battery, less cost, and your power density and the life cycle of the battery is medium. So whenever you want performance is okay with that battery, that time you can choose the lead acid batteries. So when you need good performance, good life cycle, so the best candidate is lithium ion batteries. So this lithium ion battery cost is higher side, right? Higher side. So that's what you can see here. Even in India also, they are going to, I already mentioned, I think. So in India, we are going to develop lithium ion batteries. So for that, the Tata group is working in the Gujarat. So they are coming up with the huge plant to manufacture this lithium ion cells. So I think it's a breakthrough in this battery technology. Even if you say with the same size of lead acid battery and lithium ion batteries, it will have the good power density, right? Good power density as well as energy density. So here, if you say it's a lead acid battery, valve regulated lead acid batteries, it's chosen for low cost, low end EVs. And nickel metal hydride is preferred for well performed EVs. This is a little bit costlier than your lead acid batteries. And lithium ion batteries is very attractive for high performance EVs. And people are now, as we discussed earlier, they are preferring the hybridization of this battery and storage with ultra capacitor technologies, right? So that we can able to get good power density as well as energy density with the same stack. Okay, so this again the flywheel can high speed flywheel technology. So that will spin up to 60,000 RPM. So that's a huge speed, right? So for that, we have to maintain the mechanical structure and all for that 60,000 RPM. So, but when we talk about the round trip efficiency wise, this is good. This flywheel is good, but the mechanical stability point of view, we won't prefer this flywheel and storage in the electric vehicles. So another thermoelectric generator also they are proposing it, but it's not that much effective. So here the thermoelectric generators, you can put it on your vehicle to generate electricity. But however, this thermoelectric generators efficiency and all, it's a question mark. So that's what people are working on, this type of exploring the various energy sources into the system. When we come into the battery charging, so battery charging, even the normal battery charging, we know that constant voltage and constant current charging. Apart from this charging technology, people are looking forward the future technologies like wireless power transfer and all. Even people are exploring a lot of opportunities in the wireless power transfer. They are come up with a lot of converted designs and all in the wireless power transfer. So here the bottleneck of wireless power transfer is efficiency. So once you are increasing that distance, efficiency will drop. So for that, there are a lot of research papers on the wireless power transfer to enhance the efficiency with increased distance between your transmitter and receiver. That's what people are working. And another thing that battery charging, people are working on park and charge. So that means if you're driving your vehicle to the office, you can park on that parking lot. Then your battery, your EV get charged. And even if you are connecting in the home, so that can able to participate in the DRM process and all, demand response management system. So that and all is a huge opportunity in the battery charging technology. And even people are working on it to in a road, you can have the power transmitters and you'll have the receiver on your vehicle. So that receiver can charge your battery. So during the running condition, but it's not feasible for long distances. Even you have to make the separate LAN for these electric vehicles and all. So there is a huge investment in infrastructure side. So that's what people are working on it. But if you go with electrification of transportations, that means if you go with this electric train, so electric train on overhead lines, you are getting a power and you are running your engine over there, right? So that's the same way you can able to, if you are having the larger vehicles, heavy vehicles, then this for that you can have a separate LAN. In that LAN, you can just load your transmitters and you can able to charge it. That and all, it's again depending on the type of electric vehicles. So when we come into that vehicle to grid technology, that's what, once if your vehicle is coming to our electrical grid, we can use as an energy storage. So once you're using this electric vehicles as energy storage, so we can able to provide the ancillary supports to your grid, like power quality. You can mitigate the power quality issues, reactive power support, and even you can able to calculate how much of power it's generated from that renewables. That and all you can able to do it. So load balance means it's a DRM, demand response management. So this is the framework for vehicle to grid technology. So you can look at here. If I say it's this is one apartment, this is another apartment. We are having a, I can say it's a 40 vehicles here, another 40 vehicles here. So here these vehicles during night time, I can say 60% of the vehicles will be parked on the parking lots. So in the both the cases, so at least 60% means you can get 25 vehicles will be there, here 25 vehicles. So here you can say on that parking, just we are having the aggregate. Once you are connecting your electric vehicle to the point, your charger point, then this aggregator will be get to know that your vehicle is connected to this charging point. So that from the charging point itself, this aggregator able to collect the information of your vehicle details, like who's this vehicle belongs to whom and all. It can able to easily aggregate it. At the same time, it can able to read the charging levels, SOC levels, DOD, and other battery parameters can be passed to your aggregators. So depending upon, the aggregator may have that algorithm. So if your electrical network having the variable tariff, so I can say it's a variable tariff. Variable tariff means during a peak hour, 10 rupees. During an off-peak period, my electricity cost is, I can say it's a 4 rupees. So here, this aggregator, what they will do during the low, during low tariff time, it will get your EV get charged. So once during the low peak hours only, your electric vehicle get charged. During the peak hours, it discharges the battery. And selling that power to the network. So you can think of it, 4 rupees you are getting the power, and you are selling the same power to 10 rupees, right? So that means just you are earning the profit. Here. So this aggregator knows that for entire month or entire year, how much time your vehicle is connected and how much energy you consumed from the network and how much energy you are supplied to the network. Based on that, you will get, if you are having that, adjusted amount, you have to pay to the service provider. Otherwise, that is the energy service provider. So if your supply is more than the, for example, even most of the time it may happen, even in your apartment, you can say at least 5% of the people, they won't take the car out monthly once or monthly twice. So only they will use the car only twice in a month or once in a month. So during that time, all the time your vehicle will be connected to your network. So that time your battery will participate in the ancillary services. So that time you will get the benefit. That means you will get the cash reward from the service provider, right? So this and all is possible in the vehicle to grid technology, right? So this type of algorithms also will be developed, and for that your network should support. That also is very important. Even what happened, we have done some consultancy project. In that project, just we have get some a typical problem. So earlier in 2012, they have what they have done is they haven't even MNRE, they haven't given the subsidy for installation of the PV system. So one guy, he purchased for example, if I'm purchasing the PV, so I'm installing it and I'm having the net meter, right? I'm having the net meter and it's a grid. So this is a PV. So here what they have done is, if you are taking the power from the grid, the cost is 5 rupees. If you are selling the power to the grid, cost is 20 rupees. They are having this kind of tariff. So if I'm generating more power and I'm sending to the grid, then for unit I'm getting 20 rupees. If I'm taking the power from the grid, I'm getting 5 rupees, right? So if I'm generating more power from the PV and send it to the grid, means if I say that month I'm getting the less amount I have to pay to the grid depending upon the energy usage at my home. So I can say it's a home. So depending upon the usage, I have to pay to the service provider. So this guy, what he has done is, he didn't purchase any PV. What he did is, just he take the power and he put some converter over here, and again he feed it to the grid. So what will happen? He is purchasing at 5 rupees, and selling to 20 rupees, right? So what will happen? So he'll get a lot of profit, right? So this kind of policy issues are there in the system. So instead, what they have done, okay, they plan to give the subsidy for installation of the PV, but they maintain the same cost for selling and buying. So in that case, we cannot do any this kind of malpractices. So this happened actually in the in Jaipur. We went to some consultancy. And that company, he faced this kind of issues, right? So for that, for what I want to convey here is, when you are developing the algorithm, you should be very careful with all the possibilities. So that's what we want to consider. So in this V2G and G2V also, this same kind of problems may come into the picture. Okay, so how we can say the V2G can contribute in the DRM management? You can see here, that's what we will say in that DRM valid filling, peak saving and all, right? So here we can say the typical example of peak saving. So you can look at here, this blue is normal load curve. This is a normal load profile. So this is a normal load profile. And if you're not having the EV in the system, this is the profile you will get it. So for example, now I'm having the EV in my grid, so that you're connecting your EV to the network, so that you're having the energy storage in it. So because of that energy storage, during the off-peak period, you charge your vehicle. So once you are charging your vehicle, what will happen? Your load profile will go up. So during the peak hour, what you will do is just you discharge the batteries. If you discharge the batteries, what will happen? The curve will come down. That means your demand will reduced. So that we can look at here, the minimum and maximum point is only within this range. Earlier, what will happen? Your range is up to this, right? So here we can see that the load variation is decreased. So because of that, this is a win-to-win situation for the consumers as well as the operators, right? So that they do not go for addition of the capacity. Here the consumers, they will get benefit out of it, because during the off-peak period, they are charging their vehicle. So this is the advantage with the smart grid point of view. That means V2G point of view. So here, when we come into the drive cycles, there are different drive cycles, so depending upon the countries. So when you are going to deploy that EVs to the particular countries, they are having their own usage pattern, even environment condition, the road condition, everything you have to taken care of it. Even if you buy any car from the US, you cannot run it here, right? So we have to consider our road condition also. That also is very important. So the same way, for every country, they are having the different drive cycles. So for that, they are having the standards also. So with this standard, they will check their or they will test their electric vehicles. So in US, you can have US EPA driving cycles. In European, just we are having a European NEDC. In Japanese, they will say it's a 10 to 15 mode driving cycle. So whenever they are launching the electric vehicle, they have to meet the standards. So the standards are very simple. They will test their electric vehicle with different operating conditions, like city driving, highway driving, aggressive driving. So some people know, they just can put his leg on that accelerator like anything, then they won't release, right? Only horn, they will press the horn and they will keep on go on the road, right? So that is aggressive driving, conditioning test, and every kind of driving cycles will be tested in the each and every standard. So that standards vary depending upon the country. So even we can say within 500 cycle, you have to start your engine and reach to the highest speed. So that's they will say it's a cold start, a hot start, and transient phase, and how much pickup you are having. So these and all they will check with this driving cycles. So depending upon the standard, you are having this kind of test. Even highway cycle, how your highway cycle should be, depending upon the seconds, how much speed you are varying and all. They will test their electric vehicles. So normally they will say it's testing standards, or they can say it's a test bed. So each and every vehicle model will go into this dry cycles tests. So these are the process. You can look at it. I have given that standard as well as their pattern. You can go through it. I'm going to skip on this dry cycles. So what is the environment condition? What type of road you are using? Everything will be come into this picture. Okay. So here I'm giving an example of available models. So almost I'm having 50 electric vehicles. So in this 50 electric vehicles, you are having the different type of driveline and energy sources and different motor type. With that, you are having the different type of electrical machines and power converters and everything. So here you can check this Toyota one. So in this Toyota one, if you look at it, they are using the DC motor, DC brushless motors. So in this, they are having the hybrid model. The hybrid model, just you are having the gas engine, and in that just we are having the generator, and that generator connected to the inverter battery. So here this is the hybrid vehicle, so that we can have the gas and electrical drive. So at the same time, if you look at the other models, so they are having come up with the different types of drive lines, not drive lines, it's a source and hybridization. So here also just we are having the gas engine. This also is a hybrid model of Honda. So they have the 10 kilowatt permanent magnet machine. That permanent magnet machine is connected to the drive, that connected to your front wheels, that can be driven by the battery inverter, right? So these both are connected in parallel. So this performances and all, it's given in this tables. You can check it out. So here for showing that specification of each and every vehicles, I have put these slides. So even Nissan Leaf parameters, what is the acceleration, total power, torque. So that is very important. So how much, then only you can see the performance of your electric vehicle, how much battery, what is the efficiency of the electric vehicle, what is the top speed, every information is given here, right? So there are 100 electric vehicles in the market. So we put those things here. Even the Tesla model. So Tesla model, the best thing is they have the high running of the single charge. I mean, it will run 100 kilometers. Even now they come up with the 1000 kilometers range also. 1000 kilometers per charge, right? So even another thing with the Tesla is speed. So even this much speed we cannot run in our roads, right? So even that's what people are having the curiosity on the Tesla India. So Tesla India, they have come, I mean, maybe next year they may come up with Tesla cars in India. Before it, Tata going to play major market role in India. That's what even the advantage of Tata's are, in Tata, you are having the infrastructure. They are having the Tata Power. So with the Tata Power, they can go with charging stations. And Tata Chemicals, they are in the battery manufacturing, lithium-ion cell manufacturing, so that they can come up with the indigenous battery technology. So then Tata Motors, already we know. So because of these three combinations, I think in India, they will lead the market. So that's what people are expecting it. We'll see in future who's going to be a winner in that EV market. So these are the parameters of different electric vehicles. So I'll skip all those slides. So if you're really interested to compare, you can see all the parameters and compare, right? So that's what here we are doing. Now I'll jump into electric vehicle drives. So these are the different models here. Yeah. Now we can make classification of EVs. So in the classification of EVs, as we already discussed, so how much you are going to hybrid and how you are hybridizing your vehicles, that and all it's matter. Even Tata, they have launched Safari model recently. Even that Safari model is IC engine based. But what they have done the drive line to compatible with the electric drive, electrical drive compatibility. So in future, if they say in the government, so you not run any diesel or petrol based vehicles means it will very easy to modify your Tata Safari with the electrical drive. So that's what I hear. They have come up with the driveline structure with the compatibility option. So here we can see here the conventional, just we are having the fuel tank engine and it goes to the transmission. So here also the same, but you are having the electrical drive with the battery storage system. So that it's a parallel connection. It's a parallel connection. So here the advantage is just you can go with the regenerative braking also. So the regenerative braking, you can able to save 5% of the energy. So 5% of the energy you can able to save. So that also will increase the efficiency of your vehicle. So here the battery electric vehicle, this is a fully battery electric vehicle, only battery and your electrical drive and the drive line, right? Okay, so this is the detailed classification. So if you are saying it's a parallel or series, how much you are hybridizing and how you can call it as an electric vehicle. So if I say my vehicle only operated with the battery and electric motor, that you can say is a fully electric vehicle. So this model, Nissan Leaf, they have come up with the full electric vehicle. So now you can see here from the top will come in the parallel combination of your engine and your electrical drive. So here on top is a micro hybrid. So micro hybrid means is 80% of your energy comes from the IC engine and another 20% it's coming from the battery and electrical drive. Then if I say it's a mild hybrid vehicles, so in a mild hybrid vehicles, we can say 40, 60. So your battery and electric vehicles come into 60% and this engine 40%, right? So that is mild hybrid. If I say it's a full hybrid, the battery and electric drive will plays the major role. Another 20 to 30% will be your IC engine. So this is fully hybrid vehicles. So here battery, motor, that means it's a machine, and engine plays the major role in the hybridization. The series also the same way. So in the series, you can say fuel cell electric motor, that will be called fuel cell vehicles. So this also is a fully hybrid vehicle. But for passengers cars, they won't prefer this type of fuel cell vehicles, but for large vehicles, that means heavy vehicles, they prefer a fuel cell based concept. The same way, just we have said what is IC engine, what is micro hybrid, mild hybrid, full hybrid, even fully electric vehicle and all, these are discussed and given the specification. So these are the comparison of different types of EVs, only with hybrid EVs, fuel cell based EVs, and it's given the comparison in terms of propulsion, energy sources, and what are the characteristics and what are the major issues with that system and all, it's classified. Okay, so this is very much important when you are discussing about energy losses during the city driving. So if you look at the city driving, if your tank is full, this is a IC engine based. So your fuel tank is full, then you're having the IC engine. Then from the IC engine, you will get only 16% output. Then another 76% will go as a loss in your IC engine. So during the standby time, another 8% also will be lost in the IC engine. So here finally on the wheel, you will get 13%. So this is the tank to wheel efficiency. So tank to wheel efficiency, you will get 13% in IC engines. Then in electric vehicle related, due to of aero rolling, that means rolling on the road, your tire, and your aerodynamic efficiency and braking. So this and all will be divided in your electric vehicle or electric, not electric vehicle, it's a vehicle related. So we are not going to do anything with this. But here on wheel, you are getting the 13%, right? So during the city driving, so you can say you cannot go more than 50%, 50 kilometer per hour speed, so that your aero is less. So in the long drive, the aero will increase, right? Aero will increase. But here in the city drive, the braking 6%. For long drive, the braking will be less, right? So in that way, just we can compare it. So this is the vehicle related, we can say 3%, 4%, 6%. At the same time, if you look at in that highway driving, so highway driving, the aero increased and braking decreased. Braking decreased. So here the efficiency also is 19%. Efficiency, I mean the efficiency on the wheel also it's increased. That already we know that, right? So if you are going for a long drive, your mileage will be good. So when we come into the hybrid system, just you can look at it. So in a hybrid system, you are having the electrical drive as well as your IC engine. So your efficiency on the wheel, you can take 13%. But here, if you look at it on braking, we are having the regenerative braking. So because of that, we can able to save this 6%. This 6% you are sending to your battery. So that also will add up in the total efficiency of your system. So that is very much required to calculate it. At the same time, here if you look at that standby time, during standby, instead of having the IC engine on, you can have your electric drive. So that time you can save this 8% also in the system. So this and all is the advantage with the hybriding your vehicles. So when we come into this electric vehicles with city driving, so the same we have earlier we have compared. There you got 13% as output. So here you are getting the 76%. In this 76%, you can see here because of this 76%, this vehicle related efficiency are changed. So here aerodynamic 29, rolling 35, braking 11%. So in the highway, the braking will be again it's reduced because just here you're having the in this also the braking should be higher, but due to of this electric drive, you can able to apply the regenerative braking so that you can able to reduce this 11% here. So already we have discussed this, right? Well to tank, tank to wheel efficiencies. Yeah, how to choose the motor? That's very much important depending upon the requirement, application, the type of vehicle. That means the performance, cost, and everything is related to the machine selection. So if you want to go with the cheap, then the best motor is induction motors. Even there are a lot of EVs, they come up with the induction motor based. Induction motors, permanent magnet synchronous motors, BLDC, reluctance machines. So these are the machines they are using. Now they have come up with vernier based vehicles. So these are the recent developments in the EV. Excuse me. So you can choose any type of motors. So these are asynchronous machines. In asynchronous machines, you are having a screw cage, wound rotor, unipolar machines. In the synchronous, just we are having the different types. So depending upon the interior or insert permanent magnets, you can classify. And reluctance machines also plays a huge role in the EVs. So the persons who are working on the machine design, they will get a huge opportunity once this EVs in the development. I mean, still we are in the development phase. It's not full-fledged. Even I hope you know that 2 days back, they are planning to impose the scrappage policy, right? So if your vehicle is 15 years old, then that will go into scrappage. I mean, they're going to scrap it, right? So now they propose only for government vehicles. Even next 1 year or 2 years time of period, they will come up with the passenger vehicles also. So even passenger vehicles more than 8 years, you have to pay some green tax. They have introduced a new tax, so there is a green tax. So if your vehicle is 8 years old, then you have to pay the green tax. That also depending upon the age of your vehicle. That related to your road tax. That's what I heard. So even you can check it out. There were a new announcement. They are going to release that document for public and other opinions. Once it's get approved, then we have to pay green tax also. So indirectly, they are saying that just we can move to electric vehicles. They are going to give some tax rebate. I mean, tax exemption for EVs. Even they are having some plan to cut the toll charges for EVs and all. So that's what the trend is going. I mean, even 1 or 2 days back, I heard this news. You can check it out. So here there are different motors. You can use it for electric vehicles, DC motor, induction motor, permanent magnet motors, switched reluctance machines, and synchronous reluctance machines. So there are, you know that, I mean, as an electrical engineer, you know what are the advantage and disadvantage of DC motors, induction motors, and synchronous motors. So these are some examples. So which type of vehicle they have used, what type of machines. So the total we have given here. So this is based on which motor they have used. Induction motors. So these are the models. They are using the induction motor as an electrical drive. So who are specialized in that induction motor drive, just we can explore the opportunities in the EV. So PM machines. So PM machines, these are the vehicles they are using the permanent magnet machines. Nissan Leaf, Bolt and all, they are using the PM machines. Right? So even two-wheelers also, they come up with this different types of motors. So this type of scooters, they are using BLDC motors. So when you are going for low power, then BLDC motor is the best candidate. Right? So I can skip these slides already. Time up. So even it's a huge market for this kind of rickshaws. So they are the good players. They are contributing to the electric vehicles. Even if you look at the sale of Tata, almost they have increased the 30% of numbers in EVs. So, so I mean, this also is very easy for them. Also, the running cost is very less. So that's what this kind of auto rickshaws you can see in the cities. Okay, next, switched reluctance machine. There are some vehicles on switched reluctance machine. So here I want to discuss about different types of electrical drives in EVs. So that's what I put the slides. So for permanent magnet synchronous machines, just we use back-to-back converters. So by using this back-to-back converter, you can able to run your electrical vehicle. And here school gauge induction motor, just we are having this kind of power electronic topologies. So slip ring machines, already know that W-fed induction machines, that means if you are using the back-to-back converter at rotor terminals, that will act as a W-fed machines. And here rotor resistance control method. By using that, we can able to control the speed of your drive. So these same topologies, you can use it for your electric vehicle. So those who are working on the electrical drives, only thing is, if you are considering the electric vehicle, you have to look for 4 quadrant of operation. So in electrical drive, normally in the electrical drive, we will look into 2 quadrant operation. Another 2 quadrant operation we will use for generation, for example, wind turbines and all. But the same, if you combine this all 4 quadrants, that can be a EV. So people, those who are already working on electrical drives, they will get a huge opportunity to apply this power electronic converter topologies to the EVs. So this is what I plan to discuss, but here we are running out of the time, so I can stop at this point. If you have any discussions, we can have discussion for 10 minutes. I don't want to take much time of yours, so I stop it here. If you have any questions, please.
Good evening, sir. I am Dr. Jnanamurthy, Anna University, Villupuram campus. What is the difference between the battery technology and the high
ultra capacitors? Yeah, yes, ultra capacitors, or you can say super capacitors. So it's kind of is energy storage device that we can store the power. For example, I can save 1000 watts. That 1000 watts I can release within 2 seconds, 5 seconds, right? So I can say it's a high power density. If I take battery, the same 1000 watts I need, I can able to take that 1000 watts. That means in terms of energy, if you talk, you can take it for 1 hour, right? So that is called energy. So that energy density is more in the batteries, but in ultra capacitors, you will have within second you can release 1000 watts. That's it. You cannot take that power for 1 hour.
It will be possible to store the ultra capacitors, sir? Like a battery?
That like a capacitor. A normal capacitor, we are charging our capacitor in terms of charge, right? Charge in the electric field. So just once discharging the capacitors, we can say within a second you are discharging, right? So, but ultra capacitor, you can charge within 5 seconds or 10 seconds. The time period is slightly higher than the normal capacitors. So you can store the energy in seconds, right? But battery, you can store the energy over there, but you can take it for hours or many hours. So that's what the energy density, and this is power density.
Okay, sir. Thank you. Thank you.
Okay.
Nice presentations. Thank you.
Sheila from Tyagaraja Polytechnic College, Salem, sir.
Yeah, please, ma'am.
And why we are not using commercial purpose?
Sorry, I'm not getting the question.
Transfer morphology, and why we are not using commercial purpose?
That actually, when you are going with the electric vehicles, that just the orientation of that machines and all, it's in the different position. So in that case, we won't prefer that technology. Even when you are going with that manufacturing, manufacturing of that machines, that will get a lot of difficulties in it.
Okay, sir. I have one more.
Yeah, sure.
Of supercapacitors, sir. Is it possible to hybrid the electrochemical battery and supercapacitor together?
I'm just getting it. Ma'am, your voice is breaking in between. Supercapacitors?
Sir, now it's audible.
Yeah, it's audible.
And supercapacitors, sir. And how we combine or how we hybrid chemical battery and super capacitor together.
Supercapacitor. Yeah. So for that, again, we have to go with the power converters. So we cannot parallel these two. So for that, you need a different charge controllers for battery, and we have another charge controllers for super capacitors. So in that way, you can able to hybridize your end storage. So when we come into the life cycle, the life of supercapacitor also, it's depending upon the material you are using it. Even people are working on it. Even in the future, for example, in a mobile, now we are using the lithium-ion batteries, right? So here they are having the lot of wearables. So in that wearable, this supercapacitor is going to play the major role. The same way in this EVs and smart grid technology also, we are going to use this ultra capacitors or supercapacitors in parallel with the battery. Parallel with the battery means you are not going to connect direct parallel with the battery. With a converter, you are paralleling it.
Thank you, sir.
Yeah, welcome. Any other questions? Yeah, in normal vehicles also, people are exploring the ultra capacitors for starting. So that during starting, you require more power to ignite your machine, right? So that time you can use ultra capacitors. Yeah. Some candidate asked, suggest some area in EV where you can apply optimization technique. The best thing is you can, that's what I told you, aggregation of these EVs. So there is a lot of scope for applying the optimization techniques. So the placement of EVs means placement of charging stations and all that. So there you can apply the optimization technique. So it's a good scope. So already if we have some flavor in the power system, so this area will give very good opportunity for you to work. Like aggregating the battery. I mean, just we can consider the distribution system. Normally, we are connecting the charging station. We are having the charging station distribution system. So where you are placing, how you are optimizing and all, we can work on this. So any other questions? Non-contact problem.
So very good evening to all of you. I hope all doubts has been clarified. So if there is no other further doubt, we will conclude the session.
I think the topics are not repeated, right? From any other experts.
No topics repeated, sir.
Okay, that's good.
Thank you very much, sir, for your valuable information. On behalf of Department of Electrical Engineering and AICTE, express the sincere gratitude to Dr. Vijay Gumar, Krishnamurti for accepting our invitation to be a part of this FDP. Thank you very much.
Okay, thank you. Sir Kumar sir.
Vijay Kumar, sir, thank you very much, sir.
Okay, sir, thank you. So shall I leave?
Yeah, I think we can. Yeah, no problem, sir. You can leave. No problem. Thank you.
Okay, sir. Okay, sure. So if they are having any questions, just ask them to write it to me. So I'll clear. Right. Yeah, sure, sir. Sure. Thank you.
So please feel free to contact our guest speaker, Dr. Vijay Kumar Krishnamurti. So thank you.